Welcome to this video on parallel and unit vectors. Prior knowledge to this video includes knowing parallel vectors in 2 dimensions and operations with vectors. Let's talk about parallel vectors first. Let's imagine that we have a vector A, vector 2a, and vector 1 over 2a. You can notice that all of these vectors have the same direction, they just have different magnitudes. So if vector b is equal to k times vector a, then b will be parallel to a. Note that k could be a positive or negative value. So if k is negative, you will see that the direction is going to be opposite, but still parallel. And note that the magnitude of vector b will equal to the absolute value of k multiplied by the magnitude of vector a. For example, if we have a vector a with components 3, 0, 1, if we want 2 parallel vectors to it, we can just choose any random k values, for example, negative 2a, and find what that is, and we can find another vector 1 over 3a, or k can be anything, and based on that we can come up with any vectors. Let's do another example, so that the magnitude of vector b is equal to the absolute or modulus value of k multiplied by the magnitude or size of vector a from the example above. And we know that in this case, the magnitude of the vector is equal to the x component squared plus y component squared plus the z component squared. And putting all the values in from the previous example, we get square root of 40, or simplified to 2 root 10 as the magnitude of b. Absolute value of k is negative 2. The absolute value is just 2. And magnitude of a is 3 squared plus 0 squared plus 1 squared, which ends up being 2 root 10, and therefore we prove that the magnitude of b does equal to absolute value of k multiplied by the size of vector a. Now let's talk about unit vectors. We've talked about unit vectors before. Unit vector is pretty much a vector that has a length or a magnitude of 1. They're super useful in terms of showing a direction of a vector. So, for example, if we have vector A, its unit vector will be in the same direction, but it will only have 1 unit of length. This is useful in many situations. We'll talk about it a little bit later, but unit vectors for a unit vector for vector a is going to be 1 over the magnitude of a multiplied by vector a. So by dividing the magnitude, we change the length of a vector to 1 unit, but it will still have the same direction. So it will have the same direction because it still has an x component, y component, and a z component in 3 dimensions. Since a unit vector has a length of 1, so if you want a vector b of length k, which is going the same direction, then we simply have to multiply k by the unit vector. So in this case, b is equal to k times vector a divided by the magnitude of a. A divided by the magnitude of a gives us a length of 1, and vector b will be k times bigger than that. We can obtain a vector c which is in parallel with vector a but has k units of length in a very similar way, but now we have to consider that a parallel vector doesn't mean that it's going the same direction. It could also go in the opposite direction. So therefore vector c could be plus or minus k, which is the length of the new unit multiplied by the unit vector. Okay, now let's talk about collinear points. For 3 points A, B, and C to be collinear, meaning that they're going to lie on the same line, then vector AB needs to be equal to k, some scalar value, multiplied by vector BC. You can see this in a diagram. In this case, vector AB and vector BC kind of lie in the same line. And when vector AB is equal to k times vector BC, that means that they're parallel. And in this case, they both share point B, meaning that they're both going to be on the same line as well. Here's a summary of this lesson. I have fast forwarded it, so if you need, you can pause the video and write down any information that you need. We are now going to look at a few examples. For the first example today, we're going to look at collinear points. So we want to show that points A, B, and C are collinear in this example. So whenever you have a question which involves collinear lines, you need to use the property. So in this case, we want to say that vector AB is equal to K times vector BC. Or we can use other points as well. We can say AC is equal to K BC, or in other forms as well. But in this case, vector AB can be founded by subtracting coordinates of point B by point A, and vector BC can be founded by subtracting coordinates of point C by point B. Once we have that, we want to prove that BC is equal to K times vector AB. So we write vector BC, we already have it, as 16, negative 10, 2 for its component, and that's going to equal to K times negative 8, 5, and negative 1. We're going to break them down into the three different equations. So negative 8 times K should equal to 16, 5 times K, negative 10, and negative 1 times K should equal to 2. In this case, for all the three cases, K is equal to negative 2. That means that BC, vector BC is equal to negative 2 times vector AB, and therefore the three points are collinear. In this case, if the K values was inconsistent, then it is not collinear. For the second example of the day, we want to determine all vectors of length 4 which are parallel to vector A with components negative 3, 5, and 4. Let's break this down into different parts. Vector A has some sort of magnitude. We're going to find vector B, which is unit vector A with magnitude of 1. So it goes in the same direction, but only has length 1. And we can multiply that by 4, and that will give us a new vector, which has a length of 4, and it's in the same direction of A. And if we do the plus or minus, we can find a parallel line with length of 4, which is parallel to A. So the first step is to figure out unit vector B, and that's 1 over the magnitude of A times vector A. Magnitude of A equals to x component squared plus y component squared plus z component squared. And if we do all the calculation, we get root 50, or simplify it to 5 root 2. Now that we have that magnitude, we can plug it in. So vector B is going to equal to 1 over 5 root 2 multiplied by negative 3, 5, 4, the components of vector A. And vector C is going to be plus or minus 4 times that vector. Plus for the same direction, negative for the opposite direction, and vector B is a unit vector, so when we multiply that by 4, we get length of 4. So we put everything together, and that will be our final answer. So we get our final answer as plus or minus 4 over 5 root 2 times components negative 3, 5, and 2. Now, sometimes your teachers might be okay with leaving your final answer like this, but in most cases, you will have to rationalize your value there. So we get 4 over 5 root 2. We can't have root 2 in the denominator in standard form, so we have to multiply the whole thing by root 2 over root 2, which is 1. And by doing that, we will end up, and once we do that and we simplify everything, we get plus or minus 2 root 2 over 5 multiplied by the components negative 3, 5, and 2. And that's the rationalized form of our answer. I will leave you with 3 practice questions, and I will try my best to post up the solution to these in a separate video as soon as I can. I hope that this video was helpful for you in understanding what parallel vectors are, unit vectors, and collinear points. Thank you for watching.